All right, guys, I wanted to make sure that you could finish up your transformation lab. So I'm going to show you 4 different shots so you can fast forward to whatever you need to help you answer your questions. But I'm going to just start at the top here and go down from there. So if you didn't already get this, why did we have these 2 plates, the LB minus and then the LB amp minus? It really was to show me 2 different things. One was to, first of all, make sure that my bacteria were viable, and that would grow on the LB minus plate. And also, it's going to help me know that they were not antibiotic resistant already. Biotic resistant. Right, because I didn't give them any plasmids to make them resistant. Okay, and then the next 2, I'm just making sure, did the antibiotics really work? I should have none on the minus plate, and I should have a few colonies on the plus plate. So it's telling me that, whether or not the plasmids really gave antibiotic resistance. So, did the plasmids go in? So did they transform the bacteria or go in? And did they make it resistant? And were they resistant? Okay. Then my last one is really just comparing. It's really answering the question, did IPTG really turn on the glow gene? And we saw, if it turns green, then yes, it is turning on the glow gene. Okay, then the math here is really straight. You're just going to follow this example right here, but the number that you're going to change is how many transformants. So we had a couple of dishes that had 1 colony on them, so 1 transformant. We had another plate that had 3 transformants, so you would just plug either 1 into here or 3, and then the rest of these numbers are the same. We did use this concentration of plasmids. You did have a vial of 0.5 milliliters, but you only put half of it because you split it between 2 plates. So all the other numbers are the same. The only number you're going to change is transformants, but I'm going to let you do that math yourself. When we look at what factors might influence the transformation efficiency, well, how many plasmids do you use? You could also, things that would affect how well it transforms, how old your source plate was, like ours got kind of old for bacteria, or at least, and if you give less plasmids, you should have less transformants. Although I've also read that if you give them too many plasmids, they'll also have a lower transformation rate, which doesn't make total sense, but that's what they say. All right, so let's look at the next page. So I'm going to do a quick converting. So 8 times 10 to the second means 800, and 7 times 10 to the third is 7,000. So they say biotechnologists who are doing this, their transformation efficiency is between 800 and 7,000. So you can compare it to the transformation efficiency that you figured out in the last page. And we'll see that it's much lower. And so what factors could have explained that? Well, the age of our source plate, because it got a little older than it was supposed to be. Also, our water baths, especially the 42-degree one, didn't stay exactly at 42 degrees, and so that definitely could have affected its ability to, the bacteria to take in the plasmids that we wanted them to. So I think those two were key. Although in talking with Mrs. Sutphin, she was also talking about, sometimes you just get a batch of bacteria that's not great. So it could have been the bacterial batch that we got as well. That could also play a role. All right, then they start asking you just questions to make sure that you can apply and understand what it means when a bacteria gets a plasmid for resistance. So this is, I don't know if you can even see, but these two guys had a lawn, and these two guys had nothing. So the Luria broth with no plasmids, no ampicillin, sure, I would expect to see lots of growth. There's nothing to kill the bacteria, and it's full of food that they love. So this LB plate makes sense to me. It's just Luria broth. They were given the plasmid, but they didn't put any ampicillin in it. So again, here's just another regular LB plate. So yes, they would have a lawn. A Luria broth plate with ampicillin, but they weren't given any, the bacteria weren't given plasmids to give them resistance, so I would expect them not to grow anything. But this one's unusual. It's Luria broth that has ampicillin, but those bacteria were given, or at least we tried to give them the plasmid to make them antibiotic resistant, but there was no growth. So what do you think? So you need to explain what you think might have happened to give us a plate that was of bacteria that was given the plasmid, but still none of them grew. So what are some mistakes that could have been made in the lab to cause that to happen? All right, and let's take a look at this one. So which of the following statements is or are not true about bacterial transformation? So remember, we're looking for what's not true. So I have to say, the whole point of this lab was to make the cells competent. So we do want that. Transformation may only be performed using plasmid DNA containing antibiotic resistant. No, it's not a requirement. It's handy so we can pick out which ones actually got the plasmid, but it's not a requirement. All right, and then transformed cells are capable of passing their newly acquired traits into succeeding generations. I hope so. That's how we get colonies. Transformation was first discovered in the bacterium Streptococcus pneumoniae. Yes, that's what Frederick Griffith was doing. We talked about in the beginning of this unit. And cells must first be treated artificially in the laboratory before they're capable of undergoing transformation. Well, we treated ours artificially, but this could actually happen in real life as well. So it's not a requirement. They don't, must know. It can happen in nature too. Okay, and let's look at this last question on this page. Why did the recovery broth used in this experiment not contain ampicillin? Well, remember, this is recovery broth. We've just exposed these bacteria to our 42-degree water bath. And, we've put them in, we're moving them back and forth from ice to heat. They need some time to recover. If we gave them ampicillin, well, first of all, the ones that did get a plasmid, we're going to kill them all, right? And then the ones that did get the plasmids, they have hardly had the plasmid long enough to protect them against the ampicillin. All right, and then our last one. What you're going to do in number 11 is you're just going to do that same formula that you used, 3 pages back. So I want you to, I'm just going to give you some numbers to help you out. The total mass of plasmid used is, I believe, 0.05 micrograms. The total volume of your suspension, you used, 300 microliters of calcium chloride, 200 microliters of Luria broth. So you had a total suspension of 500 microliters. The fraction that you put on the plate, and actually I'm going to cross this out. The fraction of suspension put on the plate, well, you put 200 microliters on each plate. So the fraction is you put on 200 microliters of a total of, out of a total of 500 microliters. Okay, so your fraction is 200 over 500, or you could just use 2/5. This should give you then all the numbers that you need for your um, for your equation. You're just, each time for plate 1, you're going to use 17 colonies where they belong. That's the number of transformants. Then in plate 2, you've got 12 colonies. Plate 3, you have 11. Now, it doesn't show on this, but then when you're done finding your transformation efficiencies for each of the plates, they want you to also find the average. Remember, you're just going to add them up and divide by 3. All right, hope this helps to get your labs all finished.